Okay, so let's get started. How many people we got? We got 27. Okay. Okay, so yeah, we're gonna get started. So we got some, new topics today for programming. So we're gonna be going over logical, conditional statements, and then, or I guess logical operators really, and then we'll start to go over the if and else statements as well. But before we do that, I want to check in on everyone for the project again. So some people in the Discord, we kind of talk somewhat often in there, and I check up on you guys to see how you're doing. But I want to check in here too for those of you that aren't in the Discord to see how the project is going so far. So I don't know, either use your mic or put something in the chat for how it's going so far. Okay, haven't started yet. Yeah, I really recommend to get started as soon as you can. I know some people seem like they're somewhat struggling on it, so I want to get going on that. Well, you don't like programming. I mean, yeah, programming can be pretty stressful, I know. In the end, though, hopefully it's worth it in the end because, I mean, although the data that you have, it's not good, right? It's not good to see all the cases and deaths. It's still interesting at least. So hopefully it's kind of, I don't know, rewarding in the end. Yeah. Yeah, when I took this class myself, I felt like I didn't really know. Like at the end of the class, I felt like I couldn't do any programming at all still. So I want to make sure you guys don't feel like that. Okay, yeah. Yeah, Nicholas, yeah, it seems like you've gotten, I don't know, some pretty good progress so far. Miss SolidWorks. Yeah, SolidWorks is pretty good, but okay, so it seems like you guys are doing okay. There's no one saying that, I don't know, that you're totally lost, so that's good. If you have any questions, yeah, of course, go in the Discord or you can go to office hours and we could talk about it. All right, so yeah, I want to keep checking in on you guys though to make sure that you have enough time to do the project and that you can do everything that you got to do. Okay, so let's get started. Another comment. I think it's logical. I think it's just the time and the brain effort. Yeah, so like we were kind of talking about last class, I think for this project too, it's really useful to kind of think about stuff at a top level and then kind of break it down kind of section by section, and then you can get the code that you want or that you need to have. No, it shouldn't be due next week. I think I gave you guys 3 weeks, right? Did I put it on the calendar? I don't put it on the calendar, I don't think. Yeah, I don't see it on here. I gotta update that. But it shouldn't be due next week. It should be in 2 weeks from now. Unless I'm going crazy. I'll have to check that after class, and then I'll put it on the calendar. 11:09, that sounds familiar. I don't know, though. Let me check my calendar. Okay, yeah, 11:09 seems familiar. I'm gonna double check that, though. All right, so I'm gonna get started. Oh, it's on the deliverables page. Let me check that. Yeah, I know I haven't been uploading the new data every single day, but that's of course it's not necessary, for your code. It's just there so you can have new data at least every once in a while, and then you can just run your code. And if you wrote your code correctly, having new data, you can just kind of plug in those new files, and they have the same file name, so you can run your code and it would still work. Okay, yeah, it's due November 9th. All right. Okay, let's open up Matlab now.
Professor, is there like a cutoff for the new data of like deaths and cases, or is there like for example, you know, 11/7? That's as good as possible of data, or
Yeah,
do you want like
I think on the handout I said November 6th. You should
November
have it
6th?
up till then. Yeah, November 6th.
Okay.
Yeah. All right. So I uploaded, the new slides, of course, late once again, but they're there. So we left off where we were just about to start on logical operators. So we're gonna kind of go right there on the slides. What slide number? So it should be slide number 14 or 13. All right, so I just opened up my script from last time, and then we're gonna start adding new stuff. So I don't have any review plans for the beginning of this class, so we're just gonna get going on logical operators here. Okay, so we have logical operators and functions. All right, so let's actually make this full screen right now. Okay, so Matlab has 5 logical operators, or Boolean operators as they're sometimes called. So we've gone over some of these actually before. I just never explicitly stated that it was a logical operator. Or maybe it did, I don't know. So as with relational operators that we discussed last class, which was, when we have like a less than sign or a greater than sign. Let's go back to one of the tables here. So these were our relational operators. So just like relational operators, a logical operator gives us an answer that's logical. So it'll give us a 1 if it's true and a 0 if it's false. And they're also going to be executed element by element. Okay, so precedence, there are lower precedence than arithmetic and relational operators. So you want to keep that in mind when you're typing out your code. If you want to do a logical operator, first you should wrap it in parentheses. Okay, and then this is besides the not operator, which we'll talk about, we're going to have a little example for the not operator. So this will be a higher precedence than arithmetic and relational operators. Okay, so here we have a table that's from the textbook. And so I don't think you see it here, but it's really, really strange. Seems like my mic was clipping, had to adjust it. So it's really strange. If you look at some of the figures that I have from the textbook, you'll see sometimes if there's if we have the letters F and I, it doesn't show up. I don't know why. Let me go to one. So if you see here, like find A, right? F and I, that doesn't show up. So if you see that kind of weird formatting, that's why. For whatever reason in the PDF, F and I never show up if they're side by side. All right, let's go back. Okay, so these are the 5 logical operators that we have inside of Matlab. So we have the not operator and or, and then we have short circuit and short circuit or. We're not going to go over the last 2 here. We're just going to go over the first 3 because we use them most often. Okay, so we have not. This is our kind of variable to use the not operator is a tilde. So if we put that in MATLAB, that's going to return an array as the same dimension as some matrix or really just some array A. And this new array is going to have ones where A was 0 and zeros where A is non-zero. So really what that is saying is it's kind of flipping the array that we have. So again, we're going to have an example to kind of go over it, and it should hopefully clear this up because I think their definitions, while they're kind of, accurate, they can kind of seem confusing at first. And remember, when it says ones and zeros, that means a logical 1 or a logical 0. All right, the AND operator. So if we have two arrays, A and B, we're going to get a new array that's the same dimension as A and B, so they have to be the same size. And we're going to have ones where both A and B, so that's why we have AND, both A and B have non-zero elements, and zeros where A or B in this case is 0. And we have the OR operator. So for this, we use the vertical kind of line here. I don't know the official word for that. So we have A or B. That's going to return an array of the same dimension as A and B. And the new array is going to have ones where at least one of the or at least one element in A or B is non-zero, and 0 when A and B are both 0. So I'm just guessing if I'm you, none of this makes sense right now because it's pretty abstract to just read this and kind of try to visualize it on your own. So we got a few examples. All right, I still felt like my mic was kind of clipping. Again, I'll say that I hate Zoom. It doesn't handle video well or audio. Okay, that's good, Osceola. You guys did that in circuits? Oh, I guess yeah, you probably did. Yeah, okay. Okay, so here we have given two matrices, so we're going to go over the AND operator first. I think that's kind of the easiest to kind of understand here. So we have the AND operator. I took it in high school. Okay. So we have two matrices A and B. So we're going to use the AND operator to find when both of these matrices have non-zero values. If we have a non-zero value, that's going to give us a logical 1. So it's basically going to look at our matrix. If I have something that's non-zero, it's going to say logical 1. So yes, it's a non-zero value. And then if one or both of our matrices have a value of 0, that's going to give us a logical 0. Because that value is not non-zero, it's going to say nope. It's not a non-zero value, so it's going to give us a logical 0. All right, so let's go over this example. Okay, so I'm going to make two matrices A and B. I'm actually going to make a new script just so I can kind of clear everything out. I could comment out all of the variables that are already defined, but too lazy. Okay, so I got a new script here. I'll just do logical operators, whatever. Let's clear our memory. So clear and then CLC. All right, I'm going to make a section here. For our first example, I'll just call it the AND operator. Okay, so I'm going to define our two matrices here. So you see in the slides, I wrote the matrices on two lines just so we can visualize them a bit better. So I'll do A equals 2, 0. And then I'm going to put a 3 and then a 4. So this is our matrix A. If I run the code right now and I save this file, okay, I never can remember the date, 26th. Okay, so I ran the file, and then if I check our array A, then of course we see it right there. Who cares? Let's now define our other matrix here. So matrix B, I'm going to call this 5, 0, and 0, 2. Okay, so we have our two matrices. So now if I define a new kind of matrix here, matrix C, and I use the AND operator, so I'm going to say A and B. Okay, so what this is going to do, it's going to look at both of our defined matrices here, and it's going to tell me when both of these matrices per each index, because remember we go element by element, it's going to tell us if both matrices for each index is a non-zero value, or if it's not a non-zero value, it's 0, it's going to give us a logical answer of 1. So let's take a look at this. So I ran the code, and now I'm going to type in C in the command window. And we see here, it says it's a 2 by 2 logical array. So in our first value here, in the first index, we have a 1. So we have a 1 because in A, in this first index, that's a non-zero value, that's 2. And in the matrix B, that's also a non-zero value of 5. So because they're both a non-zero value, our first index in this matrix C that we created, using our AND operator, that's a 1. Okay? And that's, again, because both of those matrices for that first index, both of them have a non-zero value. Okay, and then if we go to index 2 for each of our matrices here, both of them are 0. So our logical answer for this index is going to be a 0 as well. Then if we go to the third index here, we see matrix A, that has a non-zero value, but matrix B has a value of 0. So our answer here is going to be logical 0. Because both of these indices for matrix A and matrix B, because both of them weren't a non-zero value, we're not going to have a logical value of 1. Okay, so remember, if we want to have a logical value of 1, if we look at our slides here, both of these matrices need to have a non-zero value. And then if we look at our last index for index 4, both of them are non-zero, so we're going to have a logical answer of 1. All right, does that make sense, or any questions on that? It's not only used to find non-zero values, but this is the kind of basis of, this is easier to understand this way when it's a non-zero value, but it's really just to say whether some condition is met or not. So we're going to actually have an example later on so we can, understand it a bit more. So we're going to do it for an example where we do temperature per day. And then that'll make kind of more sense. But you can kind of think of it like a 1, that just means some argument was satisfied or some condition. And a 0 means that some condition was not satisfied. Okay. All right, so now we have the not operator. So the not operator, as we kind of talked about, I don't know, 5 minutes ago, it's basically the kind of the opposite of what we just did right now for the and operator. So in this case, it's going to give us a logical 1 when A is 0 and a logical 0 when A is non-zero. So it's basically, flipped from what we just did for our example here. So for this, I'm going to just find one matrix, and then we're going to use the not operator on that matrix. Okay, so the not operator, we're going to define some matrix D. So I'll do 3, 2, 10, that's our first line, and then 0, 0, 1, that's our second line, and then 10, negative 4, 0, that's our third line. And run that, I'll press D in the command window, and then we get this matrix. There's actually one more thing I want to touch on. So if I look in my workspace here, let me resize this. So if I look at my workspace, you see that matrix C right here. It says it's a 2x2 logical, and we have this different kind of icon. So Matlab knows that matrix C is a 2x2 logical, and you kind of saw that when we type in C in the command window. It says right here it's a 2x2 logical array. All right, so let's go back to our example here with the not operator. There's a question. Will we start coding actual sections soon, or will it be data analysis stuff the whole time? We're going to start coding actual stuff soon here. Probably not this class, but probably next class we'll start. Yeah, I still got to think about your second project for what you're going to do for that. It's going to be a coding project, but I'm not sure quite yet what. Okay, so we have the not operator here. So we have our matrix D, and then I'm going to run the not operator for our matrix D. So I'm going to assign some new matrix here. That's going to be called E. And then I'll run the not operator on our matrix D. So if I run this right now, and I look at E, Then we have a 3 by 3 logical array. All right, so here our first value for D was non-zero. And because it's non-zero, it's going to give us a logical answer of 0. So remember, it's kind of flipped from what we had for our AND operator. Now, if I have a value of 0, so in this case, like our second or our fourth index right here, that was a value of 0. And because it's a value of 0, we're going to get a logical answer of 1. All right, and then we'll just look at our very last value as well. So in the bottom right of our matrix, that was a value of 0. So our logical answer is going to be a value of 1. Yeah, I think a lot of the Matlab classes, they'll have you work on a game, but they have you work in groups. So like it would be pretty involved. I think the other class they might already be starting. I know I looked at Dr. Sanders' syllabus. He's the other instructor that's teaching this class this semester. And he blocked out like several weeks to work on this project. So it'd be pretty involved to make a game and you'd have to do it in a group. So I'm probably not going to do that unless I can find a more simple game that each of you can work on. Okay, so any questions on the not operator or the and operator? All right, I know it's kind of dry right now. We're almost at our example, I think. Yeah. Okay, so we're going to go over one more here, which is the or operator. Or operator. Okay, so in this case, if we have two matrices A and B, we can use the OR operator to return a logical 1, where basically at least one of our matrices here has a non-zero value for some element in each matrix. Otherwise, the result is a logical 0. So I'm going to define our first matrix A. We have 20, 10, -2. I guess I'll go line by line again. Okay, 20, 10, -2, 3, 0, 3. And then we have 0, 0, 0. Trying to align it all so it looks good. All right, we run it and we'll type in A here. Just making sure there's no errors. All right, and we'll define B. So we have 0, 3, 4. I know my slide, the text is pretty small. And then 5, 6, and 7. And then we have 2, 3, 0. Okay, so we have A and B, and now let's use our OR operator. So let's make a new matrix here, matrix C. And we're going to do C equals A or B. So remember, our OR operator is defined by this vertical line. I don't know the actual name for that, so we just have our vertical line. So we do A or B. So now if I look at our output here for C, we have ones everywhere besides the very last value. So let's look at that. So here, for our first index, we have, for matrix A, we have 20. And for matrix B, we have a value of 0. So we only need at least one of these values to be non-zero to have a logical answer of 1. Because matrix A is non-zero for this first index, we have an answer of logical 1. And if we keep going throughout both of these matrices, we see that for all of the indices besides the very last index, all of them have at least one non-zero value that's either in matrix A or in matrix B, or maybe both of them are non-zero. For something like element 6 or index 6, we see matrix A has a value of 3 and matrix B has a value of 7. All right, so just in this case, either A or B, they need to have a non-zero value for each index if we're going to have a logical answer of 1. The very last index, this is 0 for matrix A, and 0 for matrix B. Because they're both 0, our logical answer is going to be a 0. All right, and then here is our precedence for all of the Matlab operators that we've learned so far. So you can kind of go through this, but you know, for me, I'll just be explicit all the time. For if I want to do something first, I wrap it in parentheses, and then it's usually not something that you have to worry about. But if you want to look at the precedence for all of these operators, you can go ahead and look right here. So the first one is going to be whatever we have in parentheses. Then we're going to have our arithmetic operators and our logical not operator evaluated from left to right. And we have our relational operators, so that's like less than, greater than, less than, equal to, all of that good stuff. And then we have our logical and then our logical or operator. All right, so now we're going to do an example here. So in this case, we're not going to be, just finding some non-zero value. Because, that's for most of our, applications for real life, that's not going to be applicable, or it's not going to be something that we're often trying to find, right? So in this case, we're going to make two random arrays where we have a range of dates. Actually, this will be prescribed by us. But then we're going to make a random array for the maximum temperature per day that we have. I don't know why, but it always seems like I make examples for temperature. Okay, so I'm going to do array addressing example. So you can use this kind of methodology on your project. It's not needed, so you don't have to do it this way. You can still achieve the same thing without using these logical or relational operators on your project, but it could help you out for, I'm trying to think for which one it was. There's one problem in the project where you could use some of this kind of methodology here. Okay, so let's do this right now. So again, for this example, we're just going to have a range of dates. We're going to make a random array for the maximum temperature per day, and then we're going to collect all of the weekend days. In this case, only Saturday and Sunday, where our temperature is greater than 100 degrees Fahrenheit. Okay, so just like for your project, sometimes you have to match stuff up and extract that into some array. So for example, for one of the questions you have to, or for the country, right? For all of our countries, you need to have a rolling plot where you can see for the top 5 countries, whether it's by cases or by deaths, you need to find all of the indices for each country, and then you can get all of that data for that country. So let's say we are plotting cumulative cases for the United States. So in that case, you would need to find all of the corresponding indices from our table for the United States, and then you could use that to then plot whether it's the cumulative deaths or the cumulative cases. So, in that case, we have some kind of prescribed parameter that we need to match, and then we could use array addressing to get all of those values. So we're doing something similar here. It's not exactly the same, but this will be kind of similar for some of the stuff you have to do in the project. All right, so let's get going here. So the first thing we're going to do is create our date data. All right, so I'm going to create our start and end dates. So our starting day, we're going to say that we need to make our starting date with date time. So use this function date time. I'm not sure if we explicitly gone over this before. I think we did an example last class. All right, so we use date time, and then I'm going to say that our starting date is June 1st, 2020. And then I have to specify the format that we have for our date time. So I put input format, and then our format was month. Put this down there. It was month. month, day, and then the year. Okay, and then our ending day is going to be date time, August 1st, 2020. And then again, we have to specify the input format. That was the month, the day, and then the year. Okay, now we're going to create a vector that can kind of encapsulate this entire range for our dates. Comment. Create vector for range of dates. So hint, hint, this would be something that I would do in the project. Like I was just talking about, if we want to find the indices for all of the days for the United States data, you need to find a way to get all of those indices, right? So you have to get a way to kind of match when we have our starting date and our end date, and then get all those values in between. So this is something like we're doing right here. So we're going to make our vector for the dates. So we're going to do dates. Maybe I'll call it date range. That's going to be equal to date time, and then our starting day to our end day. So if I run this code now and I go to date range in the workspace here, you see that I have a 1/62 date time vector. So, I made this vector by starting from our starting point, our starting day, and then I used the colon operator to go to our end day. And Matlab is smart enough to know that, okay, since I have a starting point for the date time and an ending point for the date time, everything in between should be a step size of 1 day. So we go from June 1st to June 2nd, June 3rd, and so on. Now, of course, for your project, you already have, you already have all of the dates basically. So you can make a vector that goes from your starting day to the end day. Now, of course, your data is always going to be updated as I give you new spreadsheets. So you should write your code in such a way where you can always just get the last value without having to manually specify what that last date is. So you have to think about how you can do that. Okay, so we did that, and now we're going to get the corresponding days of the week as a string. So in this case, we want to find each day of the week, where we can specify as Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or Sunday. So we get corresponding days of the week as a string. So for this, you don't have to do this for the project, right? I don't need to know if it's a Monday or a Tuesday or whatever, but this is for our specific example here. All right, so to do this, we have to use this kind of method here where we put in brackets day number. That's going to be, 1 through 7 for the week. And then we're going to put DOW. So that's going to be this variable that we're creating, standing for days of the week. And then we're going to use this function called weekday. And use this function weekday, that's going to give us the actual string name for whether it's Monday, Tuesday, or whatever. And then in parentheses here, we have to specify the variable that contains all of our dates. So we called that date range. So let's put that down. If I run the code and now I look in my my workspace here, I see I have DOW. I can click on that. And here we go. We have all of the days of the week for the range of dates that we created. So this starts on June 1st and it goes to August 1st. Okay, now there's something that we have to fix here. So if you look right here, it says 62 by 3 char or character. So what we have here is actually a character array. It's not a string array. So It's by 3 because that stands for each letter that we have here. So let's say I wanted to look at the very first index here in this vector. If I did DOW, so day of week, and I wanted to look at the very first row. So if I did DOW1, that's what we would initially think that we would have to do. Because we have a vector, I only have one dimension. I should be able to do DOW1. I only get an M. Because we actually don't really have a vector here. We really have an array. Because we have a character array where it's only showing us the letters for each kind of row here. So if I wanted to see an output of Monday, I instead would have had to do the first row and then all of the columns. And then I could see Monday. That's not very useful to us, so let's make this a bit easier. So instead of a character array, we're going to make it to a string array. So we'll do DOW, so we're just updating our days of the week here. So we're going to do DOW equals string, that's our function. So string, and then DOW. Now if I run it, and then I look at it in our workspace here, now you see that we have a 62 by 1 string array. So now you see it's basically what we just had, but we also we can see the actual row here that we have. And this time, if I do DOW1, then it gives us the full name for that day of the week. So we have Monday. Okay, did that part make sense? Okay, so if you ever see that you have a character array, oftentimes you're going to want to convert that to a string array because it'll be much more easy to do array addressing for a string array because you can just actually specify the actual word that you want to look at. Okay, last thing that we have to do on this slide here is create a string array for the weekend days that we want to look at. So we're only going to look at Saturday and Sunday. Okay, so we're going to do weekend underscore C. So I'm going to show you this line because again, it's going to be a character array. Here, I just want to highlight the difference. So this is actually something that we've been doing in the class beforehand, which was fine for the examples that we did before when we kind of defined an array this way, but it was never actually a string array. It was always a character array. So if I run our code here and I look at weekend underscore C, it says I have a 1x2 cell. So I have a 1x2 cell array, and then each of these cells here, that's a character array. So, I know there's maybe a lot of terms being thrown around here. So this is fine, but let's actually make it a string array instead so we can be consistent with having strings. So I'm going to do weekend equals, and to actually define a string array ourselves, we're going to use brackets and then double quotes. So we're going to do Saturday, Sunday. We'll run our code and then we'll compare this right now. So I have weekend and weekend underscore C. So weekend underscore C, this is again a cell array. And inside of each of these cells, we have a character array. And then I have our weekend, or this other variable that we just made called weekend. And in this case, this is a string array. So yeah, I would just always recommend to specify a string array. Again, it'll be easier to just reference each name. All right, there's a question. So so would this be sort of the same as looking for the data in the project as well? Like if I want to look at the US data, I can make a character array and then a string array. Yeah, you can do that, but I would just recommend just making a string array right away. If you're only looking at US data, you wouldn't even have to make a string array per se. Instead, you could do something like find ismember and then your table. And then you could just directly right here specify. You'd actually have to do it in quotes like this. United States of America. So, yeah, in this case, I know the formatting, it's almost being contradictory to what I just said, but you actually just have to use single quotes here. You can maybe use double quotes too, I'm not sure. Okay, so we made our arrays. Now we're going to make our corresponding temperature data. Okay, corresponding temperature data. So here we're going to make a random array. So your values are going to be different than mine. So we're going to do temp equals randy. Because we want random integers. And then I'm going to have a range here from 80 degrees Fahrenheit to a lovely temperature of 112 degrees Fahrenheit. Here I'm going to say length of dates. And then comma 1. Oh, date range. Okay, so what this is doing right here, I have a range from 80 degrees Fahrenheit to 112 degrees Fahrenheit. And this last part, this is where we specify the size of the array that we're making. So I want our temperature data to be the same length as our date range. And then I want just one column. So if I look at our variable temp, that's a 62 by 1 double, which is what we want. We had 62 days for our date range right here. And we see, in this case, it's a row vector of 1 by 62. And then our temperature data is a column vector for all of the temperature here. Okay, so we're going to make a table here because this is what you are often doing for your project. You're using tables. So I'm going to make a table here because why not? You might be making a table for your project to kind of better access and plot some of your data. So make a table. So I'm going to call this table daily underscore temp underscore table. Then I'm going to use this function right here that's called table, and this will just make a table for us. So here I'm going to transpose our date range vector so I can change it from a column vector, or sorry, a row vector into a column vector. And then we're going to put in the days of the week and then our temperature vector that we made. If I run this, then I can look at our table that we just made. And now we have a 62 by 3 table. So we have this first column here. This is our date range vector that we transposed from a row vector into a column vector. Then we have our days of the week that correspond to each date here. And then we have our temperature for each day. Okay. And now I'm going to rename one of the table variable names. So this is actually an issue for one of the data sheets that you have for the project. So if you were looking at the data sheet for states, so for every state that we have, the very first variable name in that spreadsheet is called states/territory, and Matlab doesn't like the backslash or the backslash. So what you would have to do is rename it. Now there might be a way to actually specify in Matlab that hey, this is a backslash character, but it would be easier for us to just rename that variable. Yeah, Eric, you got a question? All right, I'll wait for the question, but I'll keep going right now. Oh, okay, you're just disconnected. Okay, so we're gonna again we're gonna rename this first variable here And again, this is something like you have to do for your project, where for the state spreadsheet, the first column here is called states slash territory. Matlab doesn't like the backslash in there, so we're going to change it, or I guess it'd be a forward slash that they have. So you're going to change that in your project to, you can rename it to just something like states. So let's do this right now. So instead of var1, which stands for variable 1, we're going to rename this to dates. Okay. So rename table variable names. So I'm going to daily underscore temp underscore table. That's our table that we just made. Then I'm going to do dot properties dot variables. And what this does is it just accesses the properties that we have, and specifically the variable name properties that we have for our table. So down here in the command window, if I did daily underscore temp underscore table dot properties, then we could see some of the properties for our table. And this should be dot variable names. Okay, so here are all of the properties for the table, and we see that we have this kind of sub property called variable name. So that's what we're going to change right now. So if I did in the command window dot variable names, then I can see all of the variable names that we have for our table. So we're going to rename this first one from var1 to dates. So to do that, we have to put in curly braces right here, var1. So that's the variable name that we want to change. And then we're going to specify what we're changing it to. And we're going to call it dates. So now if I run that, variable names, and then I look at our table, now I just renamed that variable name to dates. All right, there we go. Okay, so now we're going to use a logical operator and a relational operator on the same line of code. Okay, so what we're going to do is make a comment, and we're going to find the weekend days when temperature is greater than 100 degrees Fahrenheit. And we're going to basically, so we're making an array here. So we're going to call this hot AF weekends. And what we're doing here is we're finding the indices for when our temperature is greater than 100 degrees Fahrenheit on our weekend days. So again, not exactly what you're going to be doing in the project, but you're doing something similar to this for a lot of the problems they have to do for the project. You have to find some indices for some specific thing that you have to find in the project. And then now that you have those indices, you can plot whatever it is that you want to plot. Okay, so we're going to do find. And again, in the project, you don't have to use logical operators and relational operators, but for some specific cases, it might be more useful or efficient. Okay, so we're going to do find ismember. And the table that we're looking at is the table that we created. So daily underscore temp underscore table. And I want to look at the days of the week. So I'm going to do dot DOW. So I just want to look at this column right here. So we're only looking at the days of the week when it's a weekend, so either Saturday or Sunday. So we're going to put comma weekend. So remember, weekend, this was a string array that we made that was called Saturday and Sunday. So in our line of code so far, we're going to find the indices in our table when we have a weekend, so either Saturday or Sunday. So we have our table here, and we're only going to find the indices when it's either Saturday or Sunday. Saturday or Sunday. Now I'm also going to add on in this line of code that not only do I want to look at the days from our date range when we have either Saturday or Sunday, but I also want to look at it when our temperature was greater than 100 degrees. So in this case, I'm going to say and. So remember, we just learned this logical operator today. So someone had a question. I forget who it was. I think it might have been Eric. I'm not sure. I forget. But there's a question for if the AND operator and all of those operators that we just learned today, if they're only used to find non-zero values. So in this case, no. We're just we're using this logical operator to say, not only do I want to look at the days from our date range when we have either a Saturday or Sunday, you also need to satisfy the condition for when the temperature is greater than 100 degrees. All right, so does that make sense? Because this is kind of a big part of our code here. If it doesn't make sense, I'll go over it again. Okay. Let's recap it really quick here one last time. So we want to look at our date range. We want to see when the days of the week are either Saturday or Sunday. Okay, so we're looking at our table. I'll open that up just so we can visualize it a bit better. So in our line of code, we're looking at our table. We're saying find ismember. So we want to look at our table here. And we're also just looking, go back over. So we have daily underscore temp underscore table dot DOW. So we're just looking at this column in our table, just this column for days of the week. So I want to find in our table and in this column, when the days of the week are equal to our values for our variable that was called weekend, which was a string array of Saturday and Sunday. So in this column, I'm only going to find the indices when it matches up to Saturday or Sunday. Saturday or Sunday, Saturday or Sunday. So all of these indices here, but I'm going to add on with the logical operator and only give me the indices when the temperature is equal or when the temperature is greater than 100 degrees. So if I run this code now, and we look at our hot AF weekend indices, we have those corresponding indices. There we go. Let's do this. Okay, so in this variable here, hot AF weekends indices, this is giving us the indices for when our weekend days of Saturday or Sunday, when that temperature was greater than 100 degrees. So for my table here, it shows row 7. So if I go to row 7, we have a Sunday, and on this Sunday, it was 112 degrees. So it was greater than 100 degrees. Then we see row 21. If you go to row 21, we have another Sunday here, and the temperature was 105. We'll go to 35. That was also a Sunday, and we have a temperature of 108. You see on line 34, we had Saturday was 100 degrees, but I said, tell me when it was greater than 100 degrees. So we don't have this index right here. And we'll look at one more. We'll go to 49, also a Sunday again, and that was 102 degrees. Okay, look at that. 55 was Saturday, 106, and we had that index right there. All right, so hopefully all this made sense now. And the last thing that we have to do here is we're going to convert back to the actual dates. So I have the indices now, but I want to actually specify the specific date when we had a weekend today when the temperature was greater than 100 degrees. So we're going to say get the dates. Get the dates when we had a kind of a long comment. When we had a weekend day greater than 100 degrees Fahrenheit. So I'm going to say hot AF weekend day equals daily underscore temp underscore table. So we're going to access our table here dot dates. I want to find the actual dates. And now here we're just going to specify those indices that we just found. So hot underscore AF underscore weekends indices. If I run our code and I look at what we just created right there, here we go. So hot AF weekend day. Then we see that for our conditions that we specified, for all of these dates, they are a weekend day when the temperature is greater than 100. So we can just confirm this kind of once again. We see June 14th. On June 14th, that was a Sunday. That was 107. Or sorry, not 107, 101. And I can also confirm that that's corresponds to our indices that we had. It says that was row 14. Was that row 14? Yes, it was. I can look at row 27. So is row 27, is that June 27th? Yes, it is. And that's a Saturday. And it was 110 degrees on that Saturday. So I just ran the code again. So if it's different indices than what I just had, a few minutes ago, that's because I ran the code again and that created a new random vector for our temperature. So remember, for your answers, they're probably going to be different than mine because we have this random vector that we're making. Okay, so that's our example there. So that's how we can use a logical operator and a relational operator together and use array addressing with a table to find specific values that we want to or that we're looking for, and then we can plot it. So now for this example, I'm not plotting it, but this is what you could do for your project, something like this. Okay, so that was kind of long, but do we have any questions on this example? Okay. See the last line? There you go. All right, so the next thing that we're going to go over is logical functions. All right, I'm going to move this back. Make this full screen. Okay, so we're going to go over logical functions now. So we've also used, no, that was it for the exercise. We found all the dates that it was greater than. Yeah, am I crazy? Doesn't class end at 11:15? Yeah, no, 11:15. It's okay. We're in the first week of the semester. Okay, so we're gonna go over logical functions. So we've gone over some of these before, and again, I never explicitly said that it was a logical function, but that's what it is. So we've been using find a lot, like we just did right now. And yeah, so remember the letters, if they're together, F and I, they don't show up. I don't know why. So we have find A, and we have all these other ones, but really find A, that'll be probably what you're going to use the most often. Okay, so we have, I'm not going to read through all of this. You can read through these on your own, but find, that's probably the biggest one here. And is INF, that's going to stand for infinity. That'll be useful. And then is not a number, that'll be useful as well. So we're going to go over an example here for is not a number. Okay, so it's often useful to combine logical functions with each other to get a more specific result. So we're going to combine our logical function find. And again, remember that's going to find our indices for something. And we're going to combine that with is not a number. So if I go back here, we have a logical function called is NaN. So we're going to combine those two functions together to find the indices in some array that we have where those indices are not a number. So sometimes when you import data, you're going to have some cells that show NaN, and you're going to want to remove those cells. So we're going to go over how to do that. I don't think this is an issue for this project, but it might be later on. I know for some of the labs that you're going to do, you're going to have to do something like this for some of them. Just in general, when you import spreadsheets, occasionally you're going to have some values that are not a number. And basically Matlab can kind of throw a fit about it because it doesn't know what to do. If you're trying to do some operation, it's not going to know how to handle that operation for indices where it's not a number. Okay, so we'll do NaN example. And then we're going to make some random vector. Well, I guess it's not random because it's random in the sense that it's arbitrary, but you can make the same vector that I'm making here. So 20, 20, 0, -1, 3, 0. And we're actually going to specify ourself, not a number. So not a number, 33, and not a number. All right, so we have our vector here, just called k. All right, so nothing too special about that. And now we want to first find the indices when we have not a number. So I'm going to show you kind of two different methods here, kind of a long way and a faster way. So we'll do, I'll call this method 1, the long way. So here I'm first going to find when we have not a number. So I'm going to do not a number underscore k equals is not a number k. Okay, so what I have here, I just made this variable that's called not a number underscore k. Then I'm using our logical function is not a number, and I'm running that logical function on the vector that we just created, vector k. So I can, our output here, it's a logical array that we get because we used a logical function. And it's giving us a logical answer for each index in our array that we made, our array k. So it's telling us, was the first element in k not a number? No, that number is 20, so that's not true. I can go on here, I'll go to index 7 here, and we see index 7 right here. That was not a number, and our function here is tell me when I have something that's not a number. So index 7, that was not a number, so here we have a value of 1. So that's saying, yep, that's true. Index 7, that was not a number. And then index 9, that was also not a number, so we have a value of 1. Okay, so we did that, and now I want to find the indices when we had not a number. So I'll do NaN underscore indices. I'll do M1 for method 1. Find. So now we're using our find function, and we're going to specify that for that logical array that we just created. Now, if I run this, it should give us an array with 7 and 9. And it does 7 and 9. So that's telling us these are our indices. So our indices of 7 and 9 for our vector k, that's when we had a value of not a number. Okay, so that's method 1. That's kind of the long way. So we'll go to method 2. This will be a more compact and efficient way. So here I can just write, or I can just find the indices when we add not a number just on one line. So I'll do not a number indices method 2, and we're gonna combine these two lines here to one line. So find is not a number for our vector k. So this is what we basically just did on our previous example, and we did find ismember, and then we were satisfying two conditions by using our AND logical operator. And I can just confirm that this gives us the values or the indices of 7 and 9. And you can see in our workspace right here it does. Okay, now if I want to remove those indices, so if I open up our workspace to our variable k, I'm actually going to make our vector here a column vector, just so I can look at it easier basically. All right, so here's our column vector right here. So I want to remove our indices or our rows 7 and 9. So remove, I guess I'll say rows that are not a number. So now I can do this by specifying our vector here that we want to remove, so k. And then I want to remove the indices that we just found, or remove the rows by using array addressing for those indices that we just found. So k, odd number, and of course I can use either method here. And then these brackets here, that's just to remove those rows. We've talked about that before. So this is saying to remove the rows that correspond to not a number underscore and underscore m1, that's 7 and 9, to remove them from our vector k. If I run this, then these rows 7 and 9, they should be removed. And then they are. So our new value for row 7 is 33, because I removed those two rows before. Okay, so this is again kind of relevant to your project. I tried making examples that could be relevant to your project because you got to remove some stuff. So for the counties, we talked about this last class. You have to remove indices where you have a county that's called unassigned and a county that's called out of country. And for the states as well, you have to remove some stuff. You have like some stuff like Guam, so a territory of the U.S. So Guam, the Virgin Islands, stuff like that. So you want to remove that stuff too. You only want to look at the states for the continental U.S. and Hawaii and Alaska. All right, so there we go. That's what you do for that. Okay, so any questions on logical operators before we get started on the next section? Okay. All right, so now we're on conditional statements. So this will be when we do if something, do something. You'll see. All right, so in everyday life, we use conditional statements to make decisions. So consider the following. If I get an A on my exam, I'm going to drink beer. Else, if I get a B on my exam, I'm going to have ice cream. Otherwise, I'm going to cry. So this is going to be similar to the kind of logical structure that we have for our conditionals, our if conditionals. So we could rewrite this instead of like this kind of sentence format. We can rewrite it in this format right here. To if I get an A on my exam, I am going to drink beer. Else, if I get a B on my exam, I'm going to have ice cream. Otherwise, so if I don't get an A or a B, I'm going to cry. And then we terminate this by putting a period. Okay, so Matlab conditional statements, they allow us to write programs that make decisions, kind of like we did up here. But of course, we're doing this in the form of a script. So the formatting is going to be very similar to what I wrote right here. So our conditional statements, they can contain one or more of if, else, and else if statements. So right here, all I have is an if statement and an else statement, but we can also have an else if statement that we'll see later on. And once we're done with our block of code, we're going to terminate it by putting, instead of a period, we're going to put an end statement. And that will terminate what we just wrote out. All right, so our basic form here for an if statement is going to be if some logical expression do what we have here in our statements, and then we're going to end it. So if something occurs, do something, end. Again, we have to always make sure that we have our accompanying end statement at the end of our block of code here. All right, so we can probably do one example, and then we're going to stop for today. Okay, so we're going to do an if statement example. I'll make a new big section like this, and we'll call this conditional statements. Man, wind is blowing so hard right now. Okay, and then I'll do a little section here for if statement example. Garage shaking, yeah. It's crazy how strong it is. Okay, so we want to compute the square root of some number if it's greater or equal than 0. All right, so here's our code. I'm in Anaheim Hills. I'm right on a slope too. I'm by the 241, so I'm not going to be any more specific, so you don't TP my house or anything. All right, so C equals 25. I'm going to say if C is greater than or equal to 0, then we want to compute the square root. So D equals square root of C and then end. I don't know why you do that. Okay, so we have here, I'm actually specifying just a scalar. So not a vector, just a scalar. I have C equals 25. And then I have if C is greater than or equal to 0, and then you're going to make some new variable D that's going to compute the square root of C. And then we're done. So we're going to put an end. Yeah, I'm sure there's not anyone that's creepy, but I'm still not going to give you my location. But yeah, I'm by the 241. It always gets super windy. All right, so let's run our code right now, and then we get D equals 5. So just computed the square root of C. In this case, it was 25. And this ran because C was greater than or equal to 0. Let's change C right now to negative 25. Now if I run the code, nothing's going to happen. So nothing occurred because this condition wasn't met. In our case, C was less than 0. So it didn't even attempt to run the code here for D. So if I type in D, then nothing occurs. We had a matrix that was a capital D before, but that's not what we want. So there's no variable that's defined for D in this case because our condition wasn't met for C being greater than or equal to 0. Let's do one more here. We'll put in like 36. We'll run that. Because 36 is greater than or equal to 0, then this line of code, line 83, that's going to run. It's going to compute the square root of 36, and that's 6. All right, so that's a very basic little intro to our conditional statements. And yeah, we're gonna expand this idea to work with vectors once we discuss looping later on. All right, so that's all I got for you guys today. So if you have questions, stick around or go in office hours. If it's a question on the project, just ask me in office hours because those are more involved. But if you have any questions about today's lecture, then stick around. So yeah, I'll see you guys on Wednesday. Office hours is at 12.
Wait, Professor